Alright, so my name's Kevin. I'm a member of the RPI Embedded Hardware Club. I'm actually the lab manager. And we have been working on this open source RFID reader project. And we wanted to design it for use by students, faculty, staff for attendance taking. And it's also a little bit hackable, so you could potentially control other devices with it. So this is actually a collaboration. It's not just open source software, as is traditional, I guess, with RCOS. It is open source hardware. So we have a circuit board design that is also on the GitHub, and it's all open source software on the device in addition to open source on the computer interface. And we've also been working on a physical case design. While I was waiting for the board, I decided that we needed a little bit more marketing. So what this is a USB compatible microcontroller-based RFID reader. You can connect over a serial port to a computer and either log data on a computer from an RFID, or power it over battery and log the RFIDs remotely, and then later upload those to the computer. And
by the way, this is how I'm going to take attendance on RCOS this time. All you have to do is bring your RPI ID and just show it by next time.
Yeah. Exactly. So this is compatible with the RPI IDs right now, and we envision like using it as a replacement for an iClicker. Sometimes teachers want you to bring your iClickers when they take attendance with a silly question or just push any random button. So having an RFID is better because you don't have to remember your iClicker. I have so many friends that forget theirs, and it's harder, or it's trickier to not be able to take attendance this way. So a little bit of background. This started about a year and a half ago. So Asher and I were roommates, and he decided that he wanted to open our door with his ID. And so he and I worked together. We modified this RFID reader made by a company called Parallax. And it came with 2 ID tags, but it was not compatible with the RPI ID encoding. So what we did was we removed the microcontroller that did all the decrypting, and then we replaced it with the same chip that is used in an Arduino, a very basic 16 or 8 to 16 megahertz processor, 8-bit, 32K flash, 1K, 2K RAM. And Asher did a great job getting that to work with very limited RAM because it takes a lot of data to pull down, and then under 8 megahertz because you have to be compatible with the 125 kilohertz signal from the RFID. So our design for the new one, it is compatible with the RPI IDs. So we can swipe any student's ID, and even anyone using the same IDs type at like a different company, they can swipe their ID and it could actually record that number, but we don't need to. And we want it to be able to be plugged into a computer, like a base station, and then you can swipe your ID and that computer can take that and either log it for attendance or open a door or enable another program to run or something like that. And then the other mode of operation is remotely. So this actually is going to have a battery. We've already got the battery circuit on our USB rechargeable battery, and you could just have the reader. And then you could place it on the table at the entry or something like that, just turn it on. And then people can swipe their IDs, and there'd be an indicator that says, okay, you're signed in, and go sit down now, something like that. And then after at the end of the class or at the end of the meeting, whoever's in charge can take this, connect it to their computer, and then download all of the IDs for all the people that showed up. There's a little bit of basics about RFID. Is everyone familiar with how RFID works? Hands? Oh, okay, I'll do this one. So the way RFID works is there's an antenna on the board, and it acts as an inductor. And if you know about inductance and magnetic fields, you can transfer electric potential through a magnetic field to another coil of wire. So in this antenna, we have one coil, and in the card we have another coil. And this has a carrier signal energizing the antenna, producing a magnetic field. And whenever the ID is brought close enough, current is induced in the ID, powering the chip in the ID. And then that modulates its impedance to change the load on this antenna, and then chip reads that load. So when you start with a sine wave, and then you end up with a sine wave with different levels of amplitude. And this chip measures those amplitude changes, and then sends that to the microcontroller for it to decode the amplitude changes. And then, like, whenever you swipe your ID to get into a building here, it is actually communicating over the network and sending that ID and location where you swiped to a central server for authentication. And if you're allowed to go in that building, it lets you. I want to make a point, though, that there's no personal data stored on here. It is one 45-bit number. There's no RIN, there's no ISO, there's nothing. It's just one number. In this system, what it does, it has to read the tag. And because of the way the differences in frequency of the reader and the microcontroller, we read about 400 to 500 bits, because it can be anywhere in that section. And then compress that section of zeros and ones. You can get like anywhere from 5 to 15 zeros in a row, and 5 to 15 ones in a row. And 5, 6, or 7 is compressed into one bit. And then, so that takes 400, 500 down to 90 bits. We can take that, which is always going to have pairs of zeros or ones. And 0, 1 is 0 and a 1, 0 is 1. Turn that into a Manchester code. Or that is Manchester encoding, so we decode it. And we can detect the start and the end tag by 3 zeros at the start and 3 ones at the end. And that represents the start and the end, because in a pair of 0, 1, 1, 0, you can never have 3 of the same next to each other, so that's how we know where the beginning is. And then once we decode the Manchester encoding, we've got 45 bits. We've got a 20-bit manufacturer code set by HID, the company that makes these. And whenever they run out of all of the 24 bits behind that, they have to roll out a new manufacturer code. Then there's an 8-bit site code, and that is unique to RPI. And in the 2 iterations of manufacturer codes, we've only found 1 iteration of site code for RPI. And then following that is a 16-bit unique ID, which is actually printed on the back of the card in the upper left here. It's like a dot matrix printer, and that can go up to 65,535. That's a 16-bit number can. And then there's a 1-bit parity, but we ignore that. That's the 45th bit. A little bit about the circuit. This is the block diagram. So the AVR is the main microcontroller. There. It communicates over USB to the user computer. USB communicates with the battery charger to charge the battery. And the battery powers a boost converter, which can power the circuit in mobile mode. It has a real-time clock for mobile mode for record the time. It's not really necessary, but I put it on there. Thought it might help. And then the microcontroller communicates directly with the RFID chip. There's a clock line and data line, so we can save power in mobile mode if an ID hasn't been detected in a while. This is about where we are. Most of what we've done so far is PCB layout. We got these yesterday. I built the first one. So the next step is testing and debug, and then we're going to work on porting the code from this microchip to the new one, the 18 mega 32U4. So there's a couple registers and lines that we need to modify and make sure that they still work. Oh, and we also need to work on computer side applications. So now I have a demo of the older circuit. So right now, this is powered clearly over USB. Just ignore the power adapter, it's not plugged in. And what's going to happen when I swipe the old ID? I'll reset it. Everything's better with blinking lights, right? Alright, so if I swipe this ID, it reads it, and you can see there, we've got the raw binary tag. There's 44 bits there. We exclude the parity bit. And then we've got hexadecimal mode, and then a decimal mode. So those are all, those 3 lines in a row are all the same tag, right? And then it reads it multiple times, just because it can. That's about how fast it reads. And we've got a pretty good read range. We get about 1.5 inches, 2 inches at best. And we could actually do software modifications to extend the read range.
Can we have one more ID so that we know the difference?
Yeah, so here's another ID. You can see completely different. Yeah, so this right here is the site code, or I'm sorry, the manufacturer code. Yeah, the 4099 is the manufacturer code for the first card, and 4098 is the manufacturer code for the second card. But the site code 56 is unique to RPI and doesn't change over these two manufacturer codes. And then if you look right here, 41414 is printed on the back of this card. So if you could take your ID, pull it out, and you would see this number, and it would scan it. The other one is 56101. So I can scan my ID. 46155. 46155. And then we've also on here, you see the flashing LED, right? It's green for this ID because it has an internal memory of what ID is good or bad. So this one, it can use the microcontroller to say open a door or trigger an event without the computers being necessary. And this one, red light is not allowed. So in this circuit, we've left ports open, we've left pins open, so that you can theoretically solder your own wires to it, build your own circuit, have an interface over that. It's got serial, it's got I2C, and it's got digital analog inputs and outputs. So you can hack it if you want, or you can use the USB interface and run the program's computer side to react based on the tags that are read and different inputs. Are there any questions? Yes?
How much do those things cost, the board you put together? As a populated PCB, if you were to make a run of, let's say, 100?
Yeah, the prototypes, this one cost about $40. If we did a run of 100, my guess is the cost would be around $20. And what we'd like to do is have them like have a union or a club provide a supply of these that could be loaned out or rented to student groups or professors on campus for either free or low fee.
So when you pay money to the RAD card, where does that information get stored?
So RAD is like a credit or debit card, and all that information is stored on the magnetic strip. The magnetic strip stores the ISO number that's printed on the front. I don't actually know if it stores any more information than that, but all of the RAD information is on the magnetic strip, and that's all done server side with authentication
and you're not reading the magnet strip?
Right, no. We're just reading the internal RFID chip, so there doesn't need to be any contact to read it.
Okay, so for the magnetic strip, you need to have a slip through something to read it, not through the RFID.
Right, and actually, if we could skim an ISO, that'd be kind of legal, because we could replicate that pretty easily, and that's not good.
We could buy you lunch using your money.
Yeah. That's right. So the other question I have is the parking is a big hazard. Can this be used for parking when you enter into that?
For like swiping it to enter the gate or to pay?
Yeah, swiping into the parking lot or something.
I don't see why an RFID system couldn't be used. I wouldn't use this one because it currently wouldn't really support like a network interface. I would use something more secure like what they have on the doors for buildings. And there are some companies or organizations that use that so that they can regulate it. It's an access control like they have at RPI. Are there any other questions? Yes.
You don't actually have a serial port, right? You're doing serial over USB? Are you using dedicated serial?
So this chip has a built-in serial or a USB stack. It's all software side, so this doesn't need a USB to serial converter. And then it has a second serial port that you can directly plug into. It's a UART.
Okay.
This one's using a USB to serial converter, but this one has a direct USB interface built into it. And actually, I have the board. I don't want to talk about this too long because we're already running late. But this is the board design.
This he has posted it in his blog that you can read his blog.
Yeah, so like, this is all the battery circuitry over here. This is all the microcontroller right here. This is all the RFID over here. And then there's these blue pads right here. Those are the external pins to break out. So if you want to use the analog, if you want to use digital, and the serial's broken out there also. And then I also wanted to show you really quickly the case design.
Dave has a question.
Oh, yes.
I have a question that you probably don't want to answer. I'm just kind of curious. Do you have any idea, let's just take, say, RPI for instance, is there any correlation between the RFID number and the number that's stored on the magnetic strip?
Not to our knowledge.
The RFID number is actually just whichever order you got your ID in. The RPI card office gets stacks of blank IDs with sequential numbers. The ISO number is actually generated through Sodexo.
Yeah, the magnetic strip on these is reprogrammable. So whenever you get a new ID, they swipe it to activate it. But the RFID number is set in stone. It's not writable. Yeah. There are different kinds of RFIDs that are writable. They do store information. The Charlie card in Boston.
Yeah,
that stores
that's what
information.
they hacked into it, right?
Yep, they hacked into it, gave themselves an infinite balance, and rode the subway for free. But this is just a number. It's not writable. It doesn't store any other information than one number. So you have to store all the other information, like who it's associated with, locally. And that's a bit of an issue at this point, but we're trying to work around it.
But it certainly needs to be copied.
Yes. We're not doing that.
No, thank you.
This is a reader only.
Good. Yeah. Yeah.
So as we sent the case out to the RP yesterday. Should be a couple of weeks before it gets printed. Designed to be injection molded. If we do decide to make 100 of them, we can order a small batch of injection molded cases and put them together.
And you should ask Dorothy to buy a